In this video, we are going to look at the solvation of ionic compounds, or in a simpler way, the process of what happens when an ionic compound dissolves in water. So first we need to review our ionic compounds. So remember, ionic compounds are made up of a metal and a non-metal. And our metals have a positive charge and our non-metals have a negative charge. So when ionic compounds are held together, we say that they're held together by electrostatic forces. This really just means that the positives and the negatives are attracted to each other, just like you would think of a magnet. Positive and negative ends of a magnet are going to be attracted to each other. Same thing in ionic compounds. The positive metals attracted to the negative nonmetals. So we have some examples of our ionic compounds, and we're going to look at how they break apart into their two different components, into their positive and their negative. So in our first example, we have sodium chloride, or NaCl. And so when that breaks apart, it's going to break into one sodium ion, which sodium has a positive 1 charge. And then it's going to also break into one chlorine ion, which has a negative 1 charge. Now, if I look at my next one, calcium oxide, or CaO, it's still going to break into one of each of them. So we're going to have one calcium and we'll have one oxygen. But if we remember our charges from our periodic table, calcium is going to have a positive 2 charge, positive because it's a metal, positive 2 because it's in the second column. And oxygen is going to have a negative 2 charge, negative because it's a nonmetal, negative 2 because remember we count over 1, positive 2. We skip the transition metals and then it goes positive 3, positive or negative 4, minus 3, minus 2, minus 1, and then 0. So our oxygen falls in our column that's minus 2. So then when we look at our third example, calcium sulfate, so this is a little bit different. So we have one calcium, that's our metal. And so calcium is still the same, it's still going to have a positive 2 charge. Sulfate though, or SO4, is one thing altogether. So those are going to stay together into one SO4, and that has a minus 2 charge. So SO4, or sulfate, is called a polyatomic ion, and there's a list of your polyatomic ions on the back of your periodic table. So if we look at our next one, we have potassium hydroxide, or KOH. Again, we have one metal and we have two nonmetals. So since we have two nonmetals, that tells me that I have a polyatomic ion. So when this breaks apart, it's going to break apart into one potassium, and then it's going to break apart into one hydroxide. And then my last one, calcium chloride, or CaCl2, when that breaks apart, my metal is calcium, and I'm going to have 1, because there's no subscript, which means it's just a 1. It's going to have a positive 2 charge. Now my other one, chlorine has a negative 1 charge, and this subscript down at the bottom means that I am going to have 2 of them. So when it breaks apart, one calcium chloride is going to give me 1 calcium and 2 chlorine ions. So now we're going to look at water, and remember our formula for water is H2O, which means in my picture, my white pieces are going to be H's. And then this red piece here in the middle, that's going to be my oxygen. So when we talk about water molecules are special types of covalent molecules. So that means they are sharing electrons to form bonds. And we're going to look at something called electronegativity for each of these atoms. So on the back of your periodic table, there's a table of electronegativity values. So if we go find hydrogen, hydrogen has an electronegativity value of 2.1. Oxygen has an electronegativity value of 3.5. If we subtract those two numbers, they have a difference of 1.4. So if we do 3.5 divided by, or minus 2.1, we get 1.4. Now in terms of electronegativity, that's a pretty big difference. So what that tells us is that our hydrogens are going to have slight positive charges, and our oxygen is going to have a slight negative charge, which means when we dissolve ionic compounds in water, our metals, or our positively charged things, are going to be attracted to our oxygen, because positives and negatives are attracted to each other. And our nonmetals, or our negatively charged things, are going to be attracted to the hydrogen parts of the water molecule. So the different parts of the water molecule are going to attract the different parts of the ionic compounds when they break apart into their two ions. A simulation to look a little bit closer at what happens when we dissolve different things. So we're going to start with just table salt. So it's made up of sodium and chlorine, so its formula is NaCl. So I'm going to shake some NaCl into, oh, helps if I hit play. There we go. So I'm going to shake some sodium chloride into the water. Now, if we notice, if we look closely at the different pieces, so over here my key says that sodium are the little pink or red ones, and the bigger ones, the green ones, are the chlorides or the chlorines. So all of the pieces broke apart, and if I shake more in, we should see the same thing happen. So they're going to break apart into their individual pieces. So if I put in 31 sodium chlorides, I'm going to get 31 sodiums and 31 chlorine ions out. So if we were able to zoom in on this, the positive sodiums would be attracted to the negative oxygens, and the negative chlorines would be attracted to the positive hydrogen ends of the water molecules. Now, if we look at some other compounds, so let's look at a different one. Let's look at silver bromide. So I'm going to shake some of this in. So silver bromide does the same thing. So as we can see, when we shake them in and dissolve, they break apart. I dissolve 20 silver bromides and I get 20 silvers and 20 bromine ions out when that happens. That's because the ratio between silver and bromine and silver bromide is a 1-to-1 ratio. The formula is AgBr. Now, if I switch to something else, let's look at strontium phosphate. So if I shake in some strontium phosphate, so this has a polyatomic ion in it. Now our polyatomic ions in this case are the green ones, so those whole things are staying together as units, and then our strontiums are breaking apart. Now this didn't all dissolve, that's because it's considered slightly soluble, and you'll see that sometimes. Not everything dissolves completely in water, but it's still breaking apart into those two ions. So our positively charged metals are being attracted to the negatively charged oxygen in the water, and our negatively charged nonmetals, or in this case, our negatively charged polyatomic ion, is being attracted to the positively charged hydrogen part of the water. So in the process of solvation, we see our ionic compounds break apart into their two pieces, and those two pieces are going to be attracted to the oppositely charged part of the water molecule.